Welcome, everyone, to today's Passive House Alberta Coffee Talk. My name is Frank Crawford. I'm the Education Committee Lead with Passive House Alberta. And today we have Leaha Maisonneuve, President of Rodicon Engineering, and she's a building envelope consultant with over 13 years of experience. And Leaha will be telling us all about some tales from the trenches and all about some building envelope failures. So if you have any questions, please put them in the chat box and we will discuss them at the end of the presentation. And with that, take it away, Leaha.
Good afternoon, everybody. Thank you for joining. Actually, a minor correction, I've actually been doing this 17 years, quite a while. So for anybody who may have known, I actually worked for a larger firm for quite a few years and then ended up heading out on my own. And in all of that time, I've come across some interesting stuff when it comes to the building envelope aspect of it. But with that said, let's leap right into it. So the practical building envelope. A lot of what I do is field work. So I do a lot of field inspections, and a lot of what I do is translating the two-dimensional document into something three-dimensional that everybody can work with. There we go. So this first one, if you'd like to take a read, I actually pulled this from Joe Steeper's book. This made me laugh because it basically discusses the concept of building envelope. And this was from an architectural handbook that was written in 27 BCE. So this is not something new by any stretch of the imagination. A building built in one place is not going to have the same properties as a building built in another place. To further complicate matters, of course, we are having constant evolution in materials, which further complicates something that should be, in my opinion, something fairly straightforward. All right, so with that in mind, what is the building envelope? So essentially, it is what keeps the temperature, and it basically is used to, as you see, regulate temperature, airflow, and moisture, light, sound, and contaminants. Often the temperature, airflow, and moisture, those are the things that, as a building envelope consultant, these are the aspects that I pay particular attention to. In mitigating these things, light, sound, and contaminants often are also addressed. So with that said, focusing on the first three aspects of this, what are their basic three major concepts that I keep in mind when I'm doing this? So as you see, I'm looking at the watershed and the drainage plane. This involves the roof, the walls, and the foundation are all counted among that. Then, of course, the second aspect of this is air leakage versus vapor diffusion. And water in vapor form and water in bulk moisture form do tend to act differently. And it behooves us to understand how that concept works and why we get the failures we do when it's vapor diffusion versus air leakage. And then, of course, which leads to the last part, water leaks. What are they and how do they happen? So stepping on to the first aspect, we have the watershed and the drainage plane. So this is something that should always be, is probably one of the most important aspects. So whether this is your roof, your foundation, walls is primarily where they see this, it's made up of two aspects. So the watershed, this is the thing you see, the cladding, the stucco, the brick, all of that. This is going to deflect, as you see, most of the moisture that hits it, 80 to 90%. But we never expect this to be watertight. It will always have a leak, a small drip, capillary action. Water will always get through. But 20%, 10 to 20% of moisture when you're dealing with the rain, in our climate in particular, and I'd like to make that very clear, is not catastrophic so long as you have a decent drainage plane. The drainage plane, this is what we see as the Tyvek, the building paper, some of the self-adherent products that we see on walls. This is the layer that I am most concerned about because this is your final layer of protection. And this is often where penetrations are sealed, windows are tied into, doors, decking, all of those aspects. Roof to wall joints are another problem. And this is the one that we have to make absolutely sure is continuous. So if I was looking at this on a drawing, I should be able to take my pen from the bottom of the foundation and draw a line all the way up and across the roof and back down again. And this line should be continuous. a quick jump into air leakage versus vapor diffusion. So vapor diffusion, this is, you have vapor, moisture in the form of vapor that is in your ambient air. When materials are tested, they're testing to see how much of this vapor is transmitted through an area of material. This is assuming no holes, no joints, no penetrations, nothing. So the actual diffusion through a material is generally quite low. Where things tend to go sideways for us is evidently air leakage. So I love this particular graphic below because this basically defines what I see in the field more often than not, where a lot of problems come from. So air leakage takes that nice warm moisture and then proceeds to concentrate it through a hole in the wall. In doing so, we end up transporting an excessive amount of moisture into the wall cavities for the most part, and sometimes into attics, which is known as attic rain. And this is where we get most of the moisture buildup problems because it concentrates the moisture in a particular area, whereas vapor diffusion tends to be exactly that. It's diffused through the system. And we're dealing often, especially in residential, with systems that are considered reservoir assemblies, where, for example, the wood will uptake some of that moisture and release it slowly back into the system. Therefore, it's not really much of a concern. So we get a little bit of breathing. When we have air leakage, though, that condensation has a tendency to build up in a way that the system cannot uptake and then release slowly at a later date. So of things that I am most concerned about, I am most concerned about air leakage, especially in our climate. And then, of course, the third major concept is the leak. You do, in fact, need a few factors for a leak to happen. Obviously, you need a water source. Rain is the primarily the biggest problem, of course. Snow. Snow is generally a bigger issue if it can rest on a horizontal surface and be allowed to melt. But it is also a risk in its own right. And of course, man-made. When we say man-made, think of all the sprinklers that you've ever seen pointed back at a building. That has often been a problem where they have not necessarily understood that if you keep soaking the stucco, for example, you're going to saturate the surface. It was never meant for that. Then, of course, you're dealing with the actual physical holes. So if you have cracks in your concrete, gaps in transitions in buildings, of course, that's a fairly common one. Again, this is where the concept of your drainage plane becomes incredibly important at that point. So you can have gaps in your transition so long as if the water can get in, how's it going to get out? And then, of course, the driving force. Capillary action is something that you will see wicking. This is when we have materials often that are in contact with each other, which is why in code we often require a capillary break. Gravity, I think, is fairly obvious, rain coming down, which is why if items are lapped correctly, which is something I emphasize during my reviews, this will mitigate a good majority of the issues. Air pressure difference, this one, if you have a wind-driven rain, absolutely. I have watched rain become vertical as it comes up and is driven up under soffits or over parapets of buildings, for example. So air pressure will tend to basically nullify gravity in that respect. So, which is then to kinetic energy, to wind. So air pressure, wind. Wind is your a big problem when you're dealing in commercial buildings, obviously, because it can force moisture to build up in strange places. Think of all the snow that builds up on the corners of roofs. That's why wind uplift is a big issue in the outside corners. But it also means that we can get interesting moisture accumulation in strange places as well. So those are, in a really quick nutshell, sort of three fundamental aspects of a building envelope that we will now then translate to what does this look like in the field. So before I get into some of the actual failures that I've seen, some of the root causes that I've noticed where a lot of this comes from. Design versus reality. I see a lot of designs where you see an elevation, you see materials, but the transition between these hasn't necessarily been thought out. The three-dimensional aspect, and does the trade understand what they're dealing with? Closely followed, obviously, by trade competency. New products are constantly coming on the market, and some old products have been on the market a long time, but they've been tweaked slightly. So acrylic stucco comes to mind as a good example of that. How do they understand how things have changed? And are they keeping up with those installation methods? And are they accepting of new methods? Sequencing. My good gods, this one is the difficult one to try and work through because we're dealing with weather, with product supply, finances. Unforeseen conditions can often put a real hindrance on this. So depending on sequencing, a lot of problems can stem from something very simple as one trade got there before another, which then obviously leads to trade overlap. If the trade that comes after covers terrible work that happened before, that he who touched it last essentially is responsible for it. If you saw the mistake, and this requires that every subsequent trade that sees the thing understands the assembly. And then, of course, unforeseen conditions. Every once in a while, you do all the right things, and Mother Nature still finds a way. All right. Oh, I apologize, folks. There we go. So, with that said, let's get into a few issues that I have found in the field. So this is a recent one. If any of you follow my LinkedIn, some of these will probably be very familiar to you. So this particular building, I actually looked at this at the Batten Poly stage about a year ago. So this is quite recent, and the occupants have only been there for a few months. It is a typical wood frame construction. Most of what I'm presenting here is today. Typical 2-foot overhang, nothing particularly elaborate, blown in fiberglass insulation. Things to note though, the interior humidity was quite high in this house. And what they were finding is that they were having condensation build up on the windows, absolutely. But what we were really finding in the upper left photo, you'll see, that was actually a picture of mold that had started to accumulate on the surface of the drywall of the ceiling. The IR image below, of course, is what we took before we got up into the attic space to discover that just because of the orientation of this building, which is located in the southwest portion of Calgary, which if you're aware of Calgary, we have quite a few different microclimates, and the wind down there, and in particular where this building was located on the property, was just perfect. And it looks like that it was coming in through the soffit. It had wind scoured this section, fully exposing the backside of the drywall. And that, coupled with the high humidity that we had in the building, basically resulted in condensation forming fast enough that mold could form. This is a simple case. What we're going to do here is we've discovered that the blocking, the ventilation on this is front to back. Obviously, the gable is solid. The remediation for this is going to be closing up the gap a little bit so that we have minimal gap between the underside of roof sheathing and the blocking at the end of the soffit, and then put a few insulation stops in there to have the airflow flow up the surface, or the underside of the roof sheathing, so that it's not directed directly into the insulation to move it again, because this condition will reoccur. On to the next one. So this is something that I'm seeing in the field frequently. And this goes, this follows under the aspect of trade competency and understanding. This also follows with sequencing and shortcuts, let's be honest. So, and this is a project that's currently in progress that I have at the moment. It again is a typical wood frame construction, and portions of it, as you see, are going to be stucco. Often what happens is the stucco claddor is there first because they want to install the interior finishes, and the mechanical and electrical penetrations are often done after the fact. What's I'm finding particularly frustrating in all of this, and you see here, is instead of properly peeling back the paper and lapping these components in, and a lot of them now do have flanges on them, so you can treat them a lot like windows, where you can lap them properly and seal them properly into the drainage plane. They've been relying on chemical bonds, basically, with self-adhered membranes. And it should be noted that self-adhered membranes, there's no real documentation out there that says that that's an acceptable method of application. And for me, this ends in upward laps because the membrane is just attached to the paper. And in a lot of cases, the membrane just doesn't stick. By the time I come back a week later, it's already peeled off. So that is not meeting the intended performance at all. So as you can see in this, the electrical was added, and well, they slapped a very good membrane on and it was stuck very well. By the time I came back a few weeks later, this was already starting to peel off. What I don't get is the next photo below, of course, where clearly they understood that they had to get everything tied in, but then just slapped the flashing over top of the paper and then put the stucco stop over top of it. And that clearly doesn't meet code. Code does, in fact, require that your flashing be inbound of the drainage plane. Often what happens as well is we have telecommunication wires that are punched through after the fact. So the upper photo there indicates this is, I believe this is telephone lines. And then I come back a few weeks later and they've now installed this box. Well, this box has now somehow been fastened over top of it. No effort was made to remove the paper or seal it back to the sheathing, which is what I'm looking for. Plus, the way that the box is built, I'm not entirely sure how they're going to flash that so that we don't have water sit on the top of it and drain back into the wall. Of course, the first photo that you saw in the previous slide, I go back again a few weeks later and I have the bottom fix. So now that they know that they've been caught and the flashing needs to be lapped properly, they just applied a piece of membrane. And then when I indicated that that was incorrect, I came back again, only to find that they put a piece of paper to meet that portion of the code and then sealed that using self-adhered membrane. You don't want to rely on chemical bonds. Mechanical laps will ensure that your water shedding will be as robust as possible. For the most part, a lot of these claddings are relying on gravity to make sure the water gets out of the system. So don't give it any opportunity to peel a piece of material back and get into critical penetrations. The upper left photo there, this one made me chuckle only in that the vent that was installed above it was installed correctly with all portions properly sealed and lapped with the surrounding building paper, and then somehow the electrical light below wasn't. They clearly know what they had to do, so very much trade competency in this. Another aspect I'm often seeing with stucco trades lately, and this is something that I cannot stress enough, is they will go through and they've been taught that they need to seal all penetrations, which unfortunately includes the bottom flanges of windows. Don't. Please don't. If you ever see this, always remove this. So I'm going to have to request, and they're going to have to be very careful about this now because the paper is now covering a windowsill detail that was previously done that was intended to be tied into this drainage plane. So you'll often see that there'll be a little strip of tieback and then the paper underneath it. This is ensuring that the windowsill detailing that is installed long before this all goes on is lapped correctly, positive laps to the exterior. All right. Sorry, I'm going through these fairly quickly because I had a hard time trying to condense it down into little bite-sized bits. There's a lot of little failures that are out there. All right, so moving on to an aspect of leakage and moisture infiltration. This is an actual leak that occurred. This, again, is a retrofit that's currently in progress. The building itself is about 10 years old, but it's one of those typical infills that you see. And for whatever reason, they're absolutely in love with installing these vinyl decks, and they're installed over a heated space below. So in the larger deck area, there is in fact spray foam to underside of deck. There are two drains that are located here. And on either photo, you can see here that there is a curtain wall system that has been installed. I don't know how familiar people are with curtain wall out there, but it is a bit of a misnomer. Curtain wall is not a wall. You should consider it a window. It still requires detailing to ensure that you have a transition between what you're using as a floor and the actual window system. And the best way to achieve that, for the most part, is to install a curb. So in this scenario, what we discovered is that the vinyl was installed flat, and then the curtain wall was installed directly on it. So there was no back dam. There was, in fact, no sealant, and there was absolutely no way to stop the water that was sitting on this exterior deck from seeping in between the vinyl and the bottom of the curtain wall directly to the interior. So what that looked like, so this is some of the exterior photos. You can see the ponding that was occurring in the corner, which coincidentally was active leakage was occurring at the time. There was, of course, a sill flashing that was installed, but that, again, is an incorrect understanding of what this flashing and this termination was meant to achieve. So they put this in, but didn't address the fact that there was a giant hole adjacent to the door. The hole that you see cut in the field, they were just confirming the spray foam. And while the spray foam itself was actually okay, the water was seeping in at the perimeter and then saturating the entire deck surface between the vinyl decking and the sheeting. And leakage was starting to then track down through the roof drains. You will notice, of course, that there was a liquid applied membrane that was applied to this joint. That was done after the fact as part of the remediation to keep the leaks from getting in. And it didn't help. So what did that look like on the inside? So this is what it looks like on the inside. The upper left photo, of course, matches up in that corner where I was standing, where you could see the ponding, and it was actually still actively leaking at the time. The line of the joists is, in fact, in line with the curtain wall above. So it didn't take a long time for this to deteriorate. This is actually this caused structural damage, obviously. So these joists are going to have to be removed, this whole section of roof removed, and a portion of the adjacent wall where the mushroom is growing, as you'll see in the top right photo. As you come along, you can see it wasn't as bad on the bottom right photo, but we still had a very definite line that followed exactly where the transition between the deck and the interior space was. The simple method to have fixed this entire issue, which is turning into a huge bill, thousands and thousands of dollars, would have honestly to put a curb, raise the curtain wall, do a proper tie-in. You just need to create a proper bathtub between your exterior deck areas and your interior space. All right, moving on to a friend of mine actually ended up with this particular issue, so conductive heat loss. This is an older house that I would call a homeowner special, in that there was a lot of previous owner renovations had done this. We're going to focus specifically on a kitchen renovation that had happened. And basically the kitchen had been extended beyond the original space of the house. What we discovered is that there was virtually no slope on the roof above, and they had really, really terrible ice damming that was starting to form on the roof itself. This all came to light, of course, because they had 2 leaks that were specifically occurring along the exterior wall. And when we started to open everything up, we started to discover that there was. So here, for example, this is what the roof looked like before we started poking around. At this point, the rest of the roof surrounding has, 3, 4, some cases 5 inches of snow, except for the area that we discovered later had no insulation. So this is what conductive heat loss looks like, which of course then resulted in a massive ice dam, which formed on the outside edge 3 to 4 feet. And in some cases, the ice was between 2 and 4 inches thick. You can see in the sort of composite photo above, there's a small little black dot there. That's actually the roof stack. So that was where one of the leaks was occurring from. And the other one we discovered as we went poking around. So the upper left, of course, is the stack and the attempt of a seal. This is the incorrect material, obviously, to seal around an actual stack, nor is the stack high enough by code. We also discovered that there had been previous repairs that had been attempted using, well, admittedly, a tape that's meant to patch a roof. This is not considered a long-term fix. It's temporary until you can get proper flashings or proper saddles installed. Skylights by themselves also notoriously tend to leak. So we can see that there was a lot of debris that was filling up. There was places where, especially on the bottom right photo there you see, or bottom left, sorry, photo, that was the skylight where they'd had previous leakage occur and had taped it up. But in investigating all of that, those joints were starting to open up. There was a lot of water that had gotten under the tape, and it was starting to delaminate. Plus, if you stood on the joint between the metal roofing on the upper portion of the roof versus the lower, the roof was so saturated at that point, we discovered there was fiberboard and nothing else. It was starting to squeeze out like a giant sponge. The expansion also included a portion of the living room as well, and we didn't investigate further at this point because there was just too much that we had to look at that particular day, and there weren't active leaks occurring over the living room. But we did discover the interesting pool noodle that for some reason was used as a transition in between the upper roof and the lower roof. We haven't had a chance to go back and investigate that particular aspect of it yet. We're not really sure what it's supposed to do. Not a method I would recommend to support your flashings or provide any sort of gasket seal. As you can see, that was my knee there, and I'm probably kneeling on about 4 inches of ice that had formed on the lower living room roof as well. So this was a direct result of heat loss that was coming up through an uninsulated kitchen roof, forming massive ice, and then managed to find basically holes, and in some cases the weight opened up the bad seal, which resulted in admittedly not a lot of damage, but it was definitely going that way. So the photos as they're arranged right now, the photos on the left side, so that is looking up towards the roof, and you can see that the cavity is dry. There's no evidence of condensation, but there's also no insulation or vapor barrier in that particular area. You spin around the other way, and we can see that the stack was leaking, a little bit concerning because it was over the electrical. And on the other side, we can see that it had been leaking long enough to start to corrode the fasteners. Remarkably, considering how much water and ice was sitting on this roof, this particular area was actually in quite good condition, but it was definitely going to cause problems in the walls. So we had to close it up, get the ice cleaned off, and as last check, this is currently in litigation. All right, moving on to an aspect of vapor dry versus acrylic stucco. So acrylic stucco often gets a bad rap. Everybody is concerned because it's either going to trap moisture, and we reduce the ability for moisture to move through a wall. And this is true, absolutely. We have changed the materials and how they function in a wall. That said, though, it needs to be understood that a wall is a complete assembly, and we have a lot of hands that touch the wall. We have the insulator on the inside, the drywallers, the framers, and the cladders on the exterior, and every one of those components affects how this overall wall is going to perform. So this particular house was, as you see, was built in 2006, and the original owner is still living there. They had originally leakage that was starting to occur at a window on the main level, and they repaired it, and that was fine. But then they discovered that after going through and pulling the window and I guess redoing the tie-in, I don't know how well, that was not very well documented. Excuse me, the leaks started to happen again. And we noticed that it was dripping brown. So if anybody who does investigative work, when I see brown drips on the interior side, that to me tells me that water has been moving through the wood and picking up the tannins. And the darker that stain is, the farther the water has been traveling within the wall. So this became apparent to this particular owner because the stucco on this side only was cracking. And we started to get peels and little hairline fractures that was extending beyond the acrylic layer. It should be important to note here that there was no penetrations. There was one window above, but there was no problems that window. And there was no other reason for this wall to be seeing any sort of moisture ingress issues. What we did discover, of course, though, is that all of this tended to coincide with unsealed poly. So the upper left photo, this is actually on the side of the wall that was not experiencing problems, but they exposed it just to see what was going on. And we can see, my apologies if it's a little blurry, that the sheathing itself was actually in fairly good condition. Now, on the upper right portion, that is looking at the wall that was experiencing the problems, and it was very localized to the right side of the window, and in the lower photos, the rim joist area. What we discovered is that the poly was just wrapped up to the inside at the rim joist area and just stapled to the underside of the second floor sheathing. No attempt was made to apply Acoustiseal. No attempt was made to seal the joints. And this was where the worst of the deterioration was occurring. And I can definitely tell that the moisture was moving through the wall system and was being trapped on the exterior side. So when I do these investigations, I will often take a look at the fasteners and see where the corrosion occurred. So this tells me where the moisture has been sitting the longest, basically. So in this case, we can definitely see that all of the deterioration was on the outside sheathing and outside edges of the framing. But you can see to what extent that this occurred. So not only was the rim joist unsealed in any way, shape, or form, we also noticed that there was, in particular this area, there was a interior feature that had been closed off with drywall. But when we discovered, when we opened it up, it was a drywall port. And when I do inspections, especially for batten poly, it's very important for me to ensure that all poly joints are located on a solid substrate. This is an excellent example of where they did try to seal up the poly after the fact, but none of those joints were located on framing. Therefore, there couldn't be a compression seal between the framing and the drywall and the poly and the acoustoseal, and these joints opened up. And this was simply what happened when all of that interior air over 20 odd years got into the wall system. So this is definitely a case of air leakage, producing a lot of basically transporting that moisture into a cavity. And then the acrylic stucco, unfortunately, kind of got a bad rep in this case because it didn't allow the wall to completely dry out. And so it trapped it between the acrylic layer, and this is the deterioration we get. This is not a case of the stucco having gone bad. This is very much an incident where we are asking the poly vapor retarder to act as an air barrier within the assembly, and it wasn't. And this is the result where air leakage can result in severe deterioration. Speaking of which, this is a common factor, and I think this is going to be something that is most relevant for most people, probably in the next few days, especially my colleagues. So you often hear the term attic rain, which makes me cringe a little bit, but it is what it is. Attic rain or attic condensation basically is the buildup of condensation that tends to happen in cold attic spaces and notoriously tends to start to drip and drool when the temperatures rise above zero. In Calgary, of course, because we get a lot of dips in the temperature, this tends to happen every time we get a Chinook. And so everybody panics. It will often show at bath fans, which is fairly common, pot lights, which are another problem. And again, the primary cause of this is air leakage. So this particular residence, again, was another infill, again, was another low slope roof. Nothing particularly complicated. The owner here was secondhand, so he was not part of the original build. I was called in because during his Chinooks, he was actually hearing the sound of dripping water in his walls, which I thought was a little bit excessive. And of course, when insurance had come back to take a look at this, the resolution that was proposed was that there needed to be more ventilation. And this is something that I hear quite frequently. That would have made this entire situation worse. So it should be noted, of course, that this is a two-ply SBS roof. There was a significant attic space, of course, but on 1/3 of the roof, there had been spray foam applied to the underside of the roof deck, most likely because there wasn't enough space to use traditional batten poly and achieve the required R value, whereas the remaining 2/3 of the roof was left as traditional batten poly. The humidity in the house was within acceptable limits, both during the reinspection and the original investigation. But this frost buildup was tending to occur, as usual, during spats of between -15 and -20. And then he would hear the dripping over the next 3 or 4 days. And it was bad enough that it was starting to present at his windows in his bedroom. But it was notoriously occurring on the east side of the house. So for orientation on the floor plan in the image there, the portion that's noted as the spray foam, that was actually on the west side of the house. The rest of the roof is the east side, basically. So what we discovered in this particular investigation was that, so here you can see, an example of what that frost buildup looks like. So this was the east side of the roof. You can see the frost was quite extensive. We were also getting evidence of dripping on the surface of the insulation. So again, that sort of yellowish brown color to indicate that the water was sitting on the surface of the wood and leaching some of those tannins out. Pulled back a little bit of insulation, of course, and you could see that it was quite wet, and there's been previous evidence of staining. So water had been sitting there. And of course, it makes sense now that that water was then, as it melted, traveling in between the wall cavity. And so it was dripping down the exterior sheathing. My favorite, of course, is so we get to the IR image and we discover, as I am looking west, so I'm looking towards the transition between the batt insulation and the spray foam. And you can clearly see that there's significant heat loss. So when I was taking this image, it was approximately -18 outside, about -15 in the attic space. So quite evident that there was significant air leakage. when we started poking around a little bit, we discovered that no direction was given to the trades, 2 separate trades, spray foam, bat and poly guys, they don't talk to each other. No provision was made to transition and seal between the spray foam and the bat and poly. So the bottom images, hopefully it's a little bit clear, but you can see basically they had folded the poly up, created a nice little bag for the bat insulation, but you could stick your hand right up through and wiggle it. And so all of that nice, moist, warm air that was in this cavity below the spray foam insulation was now leaking out into the cold attic space, and it would travel along until it reached a cool surface sufficient so that it could condense. And that's why he was getting the frost that was building up on the east side of his roof. So this is definitely a case where changes were made from the original design, and the trade involved were not given how to create essentially an air seal. Back to the issue of adding ventilation, of course, had extra ventilation been added in this, it would have made the problem worse, as it would have started drawing more of the warm, moist air up into this cavity. And instead of venting all of that moisture, it would have overloaded the system even more. I'm happy to say that I actually went back and did a reinspection of the repair that we did on this. So what we did is we pulled out all of the bat and poly. Well, sorry, we pulled out all the bat insulation. We left the poly in place. And then we created a monolithic air, vapor, and thermal barrier using a closed cell spray foam, minimum thickness here of about 6 inches. And then we created a vertical transition between the existing spray foam on the underside of the roof sheathing on the west side of this roof and the remainder of the attic space. So we went back, made sure all of the mechanical penetrations were sealed properly up through the roof, as well as at the bathroom fans themselves, because they're now, of course, buried in the spray foam. And the infrared images, which you can see below here, of the same area, in particular the top right, that's looking at directly at that transition. And we can see now that the air, vapor, and thermal barrier have now been sealed up nice and tight. There was no frost in this attic when I did the review here last week when it was minus 25. It was quite cold. We can also see that while the ducts and the ducting for the bathroom fan and the stack, you can see, while they are absolutely bleeding heat for shade, but we are not getting condensation buildup around the exhaust either. So I would say that this is considered beautifully resolved. The owner at some point is going to probably add more insulation, but we wanted to make sure that the spray foam was continuous first without any air leakage issues before we topped it up with additional insulation. So this was a nice way to end the week last week. So that's an example of some of the aspects that I see. Often, for the most part, the biggest thing that I can say in all of this is that air leakage, for the most part, tends to be the bigger issue for me than water ingress. Be it leaks. Leaks are fairly easy to source. Air leakage is a lot harder and often a lot more expensive to try and resolve. So what can we do to mitigate some of these fairly common aspects on the design side? We need to have a place to start from, obviously, but we need the consultants and the owners, and in particular the trades, to have a look at these drawings, because these are the people installing these things. And what might look good on a drawing isn't going to translate particularly well into real world. Trust that there is input on your site supers that has to deal with sequencing and materials and clearances and code allowances. Let these people take a look. Also, some of the choices that are made don't allow for particularly good future maintenance. Flat roofs that are 3 stories up are not something that an owner can take a look at. We can't get into the attic space. We don't know what kind of seal is there. These are things that need to be considered from a design point of view. Transitions between claddings are an excellent example. Capstones, slope things, put a slope on something. Very simple. If you're going to have a building envelope consultant involved, which, I mean, we're happy to help if possible, what we'd like to do is be able to take a look at these drawings before anything ever goes in the ground, which is something I find tends to happen. I get drawings by the time the foundation is in the ground, so the design is essentially solid, so there isn't a whole lot of input I can do. That pushes a lot of my work to field work. So if that's going to be the case, then it's important that it's understood that a building envelope consultant is quality assurance, and that the trade and the builder should be engaged in quality control. So you see most of it, and then I should be able to show up on site and inspect as much of the building envelope as I can to be able to confirm that what we're looking at is going to work, because sometimes we have to change things in the field. Frequently, we have to change things in the field. Either materials change, clients change their mind, availability of materials will alter what we can do. So a lot of my work is making sure that we can translate two-dimensional to three-dimensional and work with the materials that we have at hand. So this involves good relationships, obviously, with the trades and with the builders. And it also means that the builders and the trades need to have good relationships too. Confirmation and performance testing, that's something that tends to happen in larger projects or prolonged projects. And if that's something that you can afford in your budget, absolutely, especially when we're dealing with air leakage. And this is something that's going to extend into new building codes, absolutely. If this is something you want to step into now, I highly recommend it. It will help provide a little bit of a starting block if you notice that you have consistent problems, to help pinpoint that and work with your trades to make those better. To that extent, then what can the GC, and so in this case, GC, builder, anybody who's essentially overseeing and controlling the project, care, that should be something that should be fairly obvious. If you're not going to engage a building envelope specialist who's going to oversee all of that, have somebody in-house who is really competent, who understands that the outside needs to stay out, inside in, and that you're going to have multiple trades and products that are going to form an assembly that are going to affect the overall performance of your building envelope. Make sure that you have good trades, good relationships with them. And if there are problems, try to identify them early. A lot of my problems tend to happen when something has been covered up, or we get a call back later, or one trade has covered up another's work. You need eyes on a site. I know it means probably more people, but it's important. Also, if you need to have a clarification, please ask. For the love of God, please ask. And then, of course, the trades. The trades are fundamental to making sure that buildings work. Therefore, they're first on site and last to see it often. So we need them to really understand how something is going together. If there's a change in materials, we need them to come forward, or if they'd like to propose their own materials. Trades have often really, really good ideas, and we don't take them into account, and we should, frankly. We should also ensure that they don't feel like they're going to be persecuted if they bring something forward, especially if it's going to affect the schedule. Understand that building envelope aspects, they might be a penny now to replace, but if you're dealing with them later, it becomes incredibly more expensive, often disruptive to the owners, and can lead to lawsuits, which I'm sure a lot of people have run into. Ask for details if you need them. Ask for clarifications. Building envelope specialists are notorious for having 100 different ways to do the same thing. So if you don't understand how this particular consultant would like to see it, great. Ask them to be able to explain it. And most importantly, don't cover up bad workmanship. If you see a thing, say a thing. You're not snitching. You don't have to name names, but we need to know if something is wrong, because the instant it gets covered, that trade essentially is going to be responsible for it. All right, so that was a bit of a sprint. I apologize, folks. Just a quick overview of some of the aspects and things that I see in the field. So if you have any questions, we can, I guess, jump to that portion now.
Yeah, I don't see any in the queue right now, but if anyone wants to ask one from what was talked about, you can put your hand up and unmute. If not, there's a few questions that were asked beforehand that we can go over it. I guess maybe one thing I would add is, I guess one of the real failings of the various building code upgrades to date is that they aren't requiring a blower door test. That's how you test air tightness. Do it when your air tightness control layer is visible, so you can actually test it, see where the errors are, and fix them when it's easy to do so. Because yeah, bringing back Leaha later on is much more expensive to fix the problem.
And a lot of those things are pretty typical, you know, windows, doors, transitions, deck to wall joints, roof to wall joints, and mechanical electrical penetrations. That's it. Those are where the problems are.
Yeah,
All right.
The flat open walls are easy. All right, question
from
Kevin. So how often do you see a lack of ventilation creating problems? The last example, there was a disconnect between the spray foam and poly, but I assume the deeper poly and bat space was vented. So can we
Yes.
over ventilate? Do we need ventilation? What's your thoughts?
So the primary culprit in a lot of what I'm seeing is air leakage. So if you're going to add ventilation, you're going to make the air leakage problem worse. So um, if you're dealing with a building that's well constructed, and we know that the air barrier or essentially poly, because frankly, that's in most residential construction, that is the air barrier in the assembly for the most part. If we're not getting unusual levels of air leakage, then adding proper mechanical ventilation is something that I think we need to look at now a lot more. If you're thinking passive ventilation in attic spaces, I'll be honest, that is the last resort that I will actually go to. That, for the most part, tends to create larger problems than it solves. Does that answer your
Excellent.
question?
Yep. Yeah, you need the air tightness first. More ventilation won't fix an air tightness problem.
No, it won't. And our biggest issue in our climate, of course, is that we have nice, moist, warm environments. And as we tighten houses up, all of those air leakage points that we used to have that would dry a house out, we don't have that anymore. So now you're starting to see scenarios where it builds up on your windows and you're getting funky condensation in attic spaces for that reason. So if that's the case, my kind and mechanical now need to really coordinate themselves.
Definitely. All right, one that was sent in before. So as a comment regarding OSB being used as a sheathing in a conventionally insulated cavity where the vapor barrier is behind the drywall. Any kind of, I guess, concerns? Is it a fairly common wall assembly? Any kind of thoughts on how to make sure if we are using OSB and poly vapor barrier, how to make it more durable?
So we've been using that for 50 years, maybe more. Absolutely. For the most part, there is no risk. You want to keep your vapor barrier on the warm side of the assembly. That's important. And because we're also asking it to be the air barrier in a lot of cases, we need it to be all efforts made to seal it as much as possible. By code, sheathings are required to have a gap between them. And that air leakage by its very nature, because it's at every joint in the exterior sheathing, unless you're sealing it up, even then, frankly, there's really no concern with OSB. That only becomes problematic if you have very unusual interior and exterior conditions. Primarily, if you have a very high humidity interior environment, then if that's the case, you're going to need to start looking at more mechanical ventilation. But long story short, OSB, nah, we've been doing that for ages.
Yeah, control the moisture where it enters at the vapor barrier and the air barrier layer, and then don't stop it again. Let it out and dry out.
Yep, absolutely.
All right, Brendan, you had a question. You can unmute.
Yes, I did. Thanks, Frank, and thanks, Leah, for the presentation. Yeah, it's interesting. I deal a lot with air tightness as well on the membrane side of things, and I even have some similar images in some of my presentations. But I was going to ask about stucco, so I felt like you're going a little easy on it. But my question was, when these drawings are crossing your desk, are you suggesting, rain screen cladding including stucco, and that's just getting ignored? Or yeah, I guess that was my question.
Yeah, you know what, to be honest, I would like to see more rain screening happen out there. Often it's cost. And right now I'm asked to do a lot of forums. I'm like, you could spend the money to have me fill this form and go out and do the inspection, or you could put a drained cavity behind it and you'll get a better wall assembly out of it and meet code. So a lot of times, frankly, it boils down to cost. And right now I've been spending a lot of effort in the last 3 or 4 months to really start pushing, especially my smaller builders, not my bigger ones, but my smaller ones, to basically upgrading their assemblies.
Yeah, moving towards kind of ephes, which has that drainage layer built in better than just straight stucco.
I'll be honest, I'm not a huge fan of ephes at all. I would rather see a traditional cementitious stucco or even acrylic stucco applied over something like Keen's drywall, for example. If you have that capillary break, so 6 millimeters is called for, Keen is generally 10 millimeters. If you put that on your walls, the chances of problems happening after that go way, way down.
Interesting. I guess we can touch briefly on condensation on windows and either airtight house. Really, that's just relative humidity and quality of windows, correct?
It is. A big part of that also, we have to teach people how to live in these houses again, right? My old house never used to do that is something that I hear fairly frequently. Things we need to, so we have deeper walls. obviously the biggest issue is we have to get heat now to those glazing units. A triple glazed unit is still not particularly stellar R value and all of that, and it's going to have a different dew point obviously than your wall. So especially if you have a high humidity environment, we have to teach people they need to use their fans. They need to run their mechanical systems a little bit better. Don't put furniture in front of your vents. That's a big one. Keep them away from the wall. If you're having particular problems, keep your drapes open. The heat needs to get to these assemblies to keep them warm, to keep condensation at bay. So as we get deeper assemblies in our walls, I can see condensation problems going up, to be honest. And if that's the case, then we're going to have to address how they're dried and how we get airflow to these. And that's going to have to be a question of teaching people how to live in these buildings again.
Yep. Yeah. You want to keep the relative humidity kind of in the 30 to probably 50 range.
50 is getting a little high.
50
40
is getting a bit
where
high.
You want to be. Yeah.
Yeah. Even in my passive house, where I have very high performance windows, I drop my humidity down to about 30% when it's minus 25 out or minus 35. This temperature, if it's only like 0 or minus 10, I can keep it up to 40%. And yeah, you need high performance windows. You don't want that condensing surface. And if you do, then you need to have airflow moving over it.
Well, and there's also, like, not all windows are created equally, obviously. Sliders are kind of the bottom feeder of window assemblies. You're going to have air leakage. Casements are better. You're always going to still have a little bit until you're starting to get excessive ice buildup that starts to freeze, or it's getting into the jam extension and therefore into the cavity below. It's not the end of the world. You're going to have some.
Yeah, but higher performance windows, part of that performance is less condensation.
Mm-hmm.
All right, another question. They have a vaulted roof with no access that will soon need to be replaced. The furnace is 20 years old. A side vent of the furnace will exhaust into the confined area and have a concern that the moist exhaust rising from into the roof space. Have you come across that? And do you need any clarification on that? Or can you speak to that, Leah?
So I'm guessing the exhaust for the furnace is down here somewhere, and you've got a cathedral ceiling above, and you're worried about basically the steam from that getting into the attic space.
Yeah, are you hearing me? Am I?
Yep. Go ahead.
Yeah, this is a single-story house, so the exhaust would come out on the west side of the house, which is catching the wind, and it's just driving it into a sort of area that's, I don't see the exhaust getting out very easily. It's just going to rise up the wall through into the roof vents, and I have a problem because I've got no access into the roof space. So I'm just wondering if this is a common problem. I'm noticing the people next door had the same thing, except their house is 2-story. So it's a long way up for this, their vent comes out, but it forms ice all the way up the stucco of their house in this recent cold spell.
Yeah.
So at least it's not getting into their roof space.
Yeah, that's for the most part, because that usually comes out at the rim, and even at 1-story, for the most part, that dissipates. If your furnace is running constantly, though, especially after the last little cold spat that we've had, yeah, it's a risk. It's honestly not something I find very often. It usually has to be a perfect storm of where your vent comes out, what your roof line is, what your intake is, what your surrounding environment is, trees, overhangs, houses, fences, that sort of thing. Fences do a lot, tend to deflect a lot of that. So how far out does your exhaust stick from the house?
It doesn't yet because I haven't replaced it. I'm still operating on the original furnace that goes out of the roof.
Fair enough. To be honest, I have never run into that being a source of problems. Okay. It would have to be a very unique storm, but if it's coming out at your rim, there should be more than enough dissipation by the time it hits your soffits that it's not going to be a problem. You're going to have more of an issue with air leakage from the inside of the house into that cathedral space than you would be from something like that.
Right. Yeah, I want to thank you for highlighting the man-made part in your presentation there, because I've just spent $10,000 fixing that where landscapers piled rocks against stucco, and then the builder, I assume builder or landscaper, put in a sprinkler system that just sprinkled most of its water onto the house, And this was a north-facing wall. So it immediately I moved in about 7 years ago. I stopped using it. But I opened it up and found the sheathing had completely disappeared. Most of the framing had gone. The windows had, like I say, it's been corrected now, but it cost a lot of money. Fortunately, fortunately, it didn't affect the main structural beam holding the house up.
That's good. I'd love to say it's an uncommon problem, and it's not. Landscapers have been the bane of my existence. I've watched them with shovels cut through my foundation waterproofing.
Yeah.
That was awesome. So
yeah.
I hear you.
Yeah, keep the wall dry and then let it out. Don't seal it from both sides.
Yeah.
Thank you.
Sorry, were you done, Fenella, or did you have anything else?
No, he muted himself. I think we're good.
Right,
Thank you, Fenella.
All right, another question. Would ceiling diffusers, so the supply airs from a furnace coming down from the ceiling, be better than coming up from the floor, because then they're much less likely to be blocked by furniture or drapes?
No, for the most part, I'm a huge fan of let's not put ducting that has to go through a polyvapor retarder. So the fewer holes that we can do, the better. Plus, it also depends. I have concerns with those assemblies as well, depending on where they are. If they don't seal the joints, if something opens up, now you're blasting all that nice cold or nice hot air into a space that shouldn't have it at all. So to be honest, I would prefer that we keep the mechanical where it is. Plus, it sort of helps with the natural mixing, right? So if you have nice, warm, hot air and you're trying to push it down, it never really ever quite reaches the floor. So,
yeah.
I'm a fan of keeping it where it is. Just be cognizant that if you have something in front of the drapes, just don't put the couch there, or keep it away like 2 feet. It doesn't need a lot. It just needs something.
Yeah. Keep heated ducts out of the adduct, and yeah, if you're trying to push air down, warm air is less dense, so it does rise. So it is harder
Even
to
high
mix.
velocity systems, they're just different animals.
Yep. All righty, we have time maybe for one more. Let's see. Check through. I guess material question. Can type 1 EPS be used as a moisture or a vapor barrier in a building envelope?
It can. That said, though, making it continuous and ensuring all the joints are taped properly, the workmanship required to make that work is absolutely not worth the attempt, to be honest. Put your insulation in, don't worry too much about it. Put an actual dedicated air or vapor barrier in. Those materials are out there and they're way easier to install than trying to do it that way.
Yeah, and you often get a little bit of shrinkage with most foams over time. So even if it is perfectly done on day one, and has to be fairly thick to meet type 1 requirements. Yes, it's tricky. Yeah,
it is.
Use material that's intended to do that.
Yeah, especially reaching back to design phase, keep it simple. For the love of gods, keep it to a few different components. Don't and things that the guy on Friday who wants to go have a beer, if he can mess up that particular application, then we have a problem, and that's a reality. So when you're choosing your materials, keep in mind how dead simple they can be to install.
Yep. And one quick follow-up, what's more moisture resistant, EPS or XPS?
The vapor or bulk moisture?
Good question. Answer both. We'll go vapor first.
So to be perfectly honest, both of them. And I actually caught the Dow rep finally admitting to this one day. So anybody who's dealt with inverted roof systems, after they say that extruded in particular isn't going to uptake moisture in its vapor form, it absolutely will. I've had to pull off 100-pound boards out of an inverted roof assembly because it wasn't bulk moisture that drove into it. It was vapor. So both of those materials, frankly, are subject to vapor permeability. Yes, there we go. Extruded takes longer. And frankly, that's why I don't like seeing the beadboard essentially used in anywhere that's going to be subgrade or it's going to be subjected to bulk moisture more than anything. But frankly, the real answer is they both are susceptible to it.
Yeah, XPS low, less so, but EPS. But yes,
Yeah.
both of them will absorb a little bit of moisture over time.
Yeah.
Alrighty,
It's
well,
yeah. Go ahead.
no, as I said, we're just about at 1 o'clock. So thank you very much, Leah, for your skill, experience, and expertise on this kind of infinitely deep subject.
Yeah, sorry, this was a very high level skim over top. If anybody has any questions, feel free to reach out to me. I'm here to be your resource for anybody.
Yep. All right. Well, I will end the recording then, and we will hopefully see you all next month at the next Passive House Alberta Coffee Talk.
Perfect. Thank you.